Bismillahirrahmanirrahim. Welcome to Easy Learn. As you know, we are discussing the magnetically connected to magnetic field lines that are transferring from primary coils into the secondary coil into in the previous episode. And this is connected with the transformer, as I already said in the previous episode. So how it is connected, let's see how the transformer works. This is the basic diagram of the internal working principle of the transformer. Suppose that there is a soft iron core. We basically use it for the transfer of the magnetic field lines that are generated due to the primary coil. Primary coil is mounted on the one arm of the soft iron core, and the secondary is on the other arm of this iron core. If magnetic field line generated here, it can definitely follow this route because this is a complete and a closed path definitely, and it is a ferromagnetic material. It has a properties to travel the magnetic field lines into a closed path. If we connect something power supply here, this will be definitely the two coils in the transformers. One is called primary. Basically, primary coil is a coil where we connect our main source. Suppose here we connect a main source, it will become, we say that this is a primary. From where we get our desired output is called the secondary coil. Remember that this is called a power. So okay, we discuss power in the next slide. First I want to explain the working. The magnetic flux generated in the primary coil, because we connect the source, is the alternating current. That means that alternating current is changing its polarity with the passage of the time. So when it's changing its polarity, it means that changing magnetic flux is induced in the soft iron core. Soft iron core has now traveled this change magnetic field through the secondary coil and completes its cycle. When changing magnetic flux passes through the solenoid of the secondary coil, then it will definitely catch up the magnetic field lines to produce a current, and we can see the deflection here. This is the basically working principle of the transformer. You can see that there is no direct contact between primary coil to the secondary coil. No direct contact is seen. All the current that is induced in the secondary coil, we call it as a EMF, electromotive force induced EMF, is just due to the electromagnetic field lines. Electromagnets or electromotive force is induced in the secondary coil with the help of changing magnetic flux, as we already discussed in the previous sections. This basically means that if suppose this coil fails or damaged or burn out, our secondary will results in catching zero current, zero EMF will be eventually zero. Then this, what happens? As a result, our transformer will be lost, but the equipment that is connected in our secondary winding will be safe, because it is a safe, no direct contact. So if it is if it was having a direct contact with the wire to the secondary coil, but as you know, there is no contact, but I am just supposing if there is a contact, then what happen? If this is a short circuit, then all the current will go to the secondary coil and our equipment will be definitely damaged. So this is a very good setup. We can say a transformer also has a safety purpose also, we can use it. So that this is the basically main formula of the turn ratio. Ns over Np is directly proportional to Vs over Pp. Remember that. For remembering this formula, we can say that Ns means the number of turns of the secondary coil, and Np means number of turns of the primary coil, and Vs and Vp, these are basically the induced electromotive force. Basically, what is electromotive force? It is actually voltage, so we can write it here as voltage. Vp and Vs remember that Vs over Vp, what is this means? This means that the secondary divided by primary. This is basically an efficiency, simply means output over input. This is our output, this is our primary, is actually our input. Suppose we are giving here 10 volt and we are getting 10 volt, it means that this is 100% result, and we can say 10 by, in this formula we can say 10 by 10 means is equals to 1. So it is an ideal scenario where we are getting what we enter into the primary, we are receiving in the secondary. Anyway, Vs over Vp is directly proportional to Ns over Np, but this is the formula for the voltage. For current, this is the inverse relation, because you know power is equals to I V. When one thing is increasing, the other one is decreasing. So this is a formula, sorry, so this is the question that comes for you. You have to answer this question. If the current in the primary alternates, means alternating current in the primary coil, as you know, this is the graph. In the secondary current, alternating current is induced in the secondary, no doubt, but there is a frequency that is also same. Main thing is the different phase shift. Why there is a phase shift? Means that this is the current in the primary, there is a phase shift. You can see when it is at, for example, 5 volt 5 amperes, then it is at 0. When it reaches to 5 ampere, then at this point this is at, primary is at 0. So there is a phase shift. Why there is a phase shift? You have to answer it. This is the formula for the voltage, this is the inverse formula for the current. You have to remember this one first formula, that means easy to remember, Vs, so Ns, very easy to remember, Vp and Np. While if we are remembering one formula, other is opposite to the first one, you can very easy to remember. Is over Ip, here it S is correlates with the P, means opposite. Is over Ip, this is the same thing, Vs over Vp, Is over Ip, but here reverse this and exchange their points, because current and voltage are opposite term. If one is increasing, other is decreasing. So easy to remember, this is a key. In ideal scenario, we can replace this directly proportional with the equals, but you know both formulas for the current and for the voltage, but this is not an ideal case. And you know, in the practical transformer, heat is generated, hysteresis loss, and other terms I'm not here discussing, because this is the introductory series. We can also even write the books on the transformers. This is a complete discussion. Just wanted to show you here that this directly proportional sign, it can't be replaced with the is equal to, because of the many losses in the transformers. So further going, we are just discussing the design, that if first coil is here, the second coil in parallel with the first coil, this is what we call the parallel wound transformers, and they are extremely compact. There is another called where they are connected in a like series. The first coil primary, and then the secondary, both have the sharing the ferromagnetic material iron core inside, and there is an outside. So they are connected in a series way. We can simply say that this is a serial wound transformer, and it can be used for the safety precautions from the television sets and other high voltage equipment. This is the this is a transformer that is called the overlapped winding transformer, because you can only see one winding here. Basically, actually what happens inside this, there is a one winding called primary. Then we are going to laminate this with the help of a sheet. Then another winding is wound on the same, that is called the secondary. You know, both the wires are coming from the same thing, and that is basically the inside principle. There are the three different types of the designs that are available whenever we wanted to wound the coils. Depending upon our needs, we can use it in our equipment. Transformer have many applications, and their So therefore here are many types of the transformer design we discuss. This is another ideology inside diagrams, that first we have a single primary winding while three different secondary winding. Means to say, there is a one primary winding, while we, according to our desire, we have a different number of turns on the same iron core. We have the iron core here, suppose ferromagnetic material. Secondary windings are wounding more than one. For example, this is have less number of turns, so we are getting here suppose 10 volts is in the primary coil. We can obtain 2 volts, then 3 volts if we have more number of turns, then 5 volts you have more and more number of turns. So this is a different way we can use the single transformer to get power to power out the many electrical appliances from the single, or we can use the single transformer to power out different type of electronic devices in a single board. And this is another way we are not using the different windings, but we are using the same winding, but we have a connection that are coming out from the windings, and we can use it. Same is the case, we can obtain different types of the voltage depend upon our connection. If we take out this connection very after just very small number of the turns, we can get small voltage here. We so different depends upon the needs what we need. And here is another case that only have one coming out, that is called the center tab, because it is coming from center. These two are necessary because two are of course required for any case, because this is the primary, this is the secondary, so two wires are coming one and one, while the third one is the secondary. So we can use this transformer in mostly used in the full wave rectifier, bridge rectifier, for converting the alternating current into the direct current. This is already discussed in the very details in the diode and application season 1 and season 2. You can go there and watch ultimately whatever you want and get the knowledge according to your needs. Anyway, this is another type of the same center tab, but here we have a common sharing this one path, and there is no path coming from this side, so it only can be used. It is a sliding contact. We can go up and down with the help of whatever you want. This is a low quality transformer. These two categories have the sliding contacts, and they are the cheaper transformers, cheap quality, because you can use this transformer by sliding it. And as compared to sliding, this is best because they have complete their connections, powerful connections. There is always a danger to lose the contact, while this case, as in the diagram F, has again a coil wounded on the soft iron core. But interesting thing is we have a sliding contact here. That means that if the input current changes or input frequency changes, the result in the output also definitely depend, because secondary is directly proportional or dependent on the input. The source if changes, you will definitely get a different variation in the output. So what you can do, you can slide this contact to vary the number of the turns. This is again a sliding view, a sliding transformer, but it is shown in the 3D diagram, and this is the inside diagram. The transformer definitely uses a soft iron core placed between the coils. Transformers are classified as a step up and step down transformer. Basically, we are interested in the voltage that depends upon the input to the output voltage, so always considering their voltage, not on the current. Step up transformer are also very important, step down are also very important. This doesn't mean that step up is mostly used or step down is mostly used, but in our ends in home, mostly step down is used. At the power generation side, step up is used. So it both have their own importance and depends upon the upon our needs, where we need it and the purpose. Step up transformer, as the name indicates, that suppose that we have a 5 volt here, step up will do it increase its potential means from 5 towards 10. If we have a 5 and we do use step down, it will maybe reduce it to 2. This basically called step down. Remember that power is equals to IV, means if here voltage is increased, definitely if we have a 1 ampere of the current here, then it will be reduced, other thing will reduce, because we have to do what we need to do, the product must be constant, product of the volt 5 into 1 5, and then if we increase the current 5 10, then we have to generate a number of, so that we can, if multiply with this current with the voltage, the overall result will be same, because power never be increased, power never increase. If we can increase the power by using the step up transformer, then why we need the generators? Just supply some voltage, get the enough voltage what you need, and this the world is going on according to your desire, and this is only happen only in dreams, not in the real life. Okay, step down transformer, basically 5 volt you are applying and you can get easily 2 volts, and same is the case if you have a 1 ampere here, your current voltage is reducing, then current will be increasing, you will maybe obtain 2.5 ampere here or so on, depends upon our ratios and number of turns. It is important to note that the coil you are wounding must be on the same direction. For example, if I am using this pattern to wound the coils in the secondary or primary, if I am trying to use this pattern from the carry on, then this pattern has maybe this is clockwise, say, and this is counterclockwise, clockwise or maybe or counterclockwise. So it means that if we have the opposite direction coil wounded on the iron core, we cannot get any voltage, because the direction must be same. There are many thousand of the application used where transformer every day. If you go and look around, where lights and motor mostly not used in the previous era, but now LED lights are using also transformers, our power supplies, our computers, laptops, where they are getting adapter, in the adapter of the laptop or adopt any adapter, it is definitely working on the transformer to step down, mostly step down is used. This is the very basic example to illustrate the formula what we discussed. Here we are using a particular transformer, means a specific transformer which has a specific predetermined, already discussed, mentioned in the question, given in the question, that number of turns. So number of turns wound, it is the 240 in the primary coil, means that this is the primary 240 number of turns, and this is the secondary coil, and number of turns is the 720. One thing is already from here can be seen that primary is low and secondary is high, means we can definitely be able to get high voltage on the other side, because number of turns are directly proportional to the voltage. If the number of the turns of the secondary coil are more voltage can be catched at the secondary side. So it means that definitely we are able to, this is a step up transformer. From here we can easily understand, because secondary winding has more number of turns. If 24 voltage AC is connected to the input terminal, we are connected with the 24 voltage here in this side, 24 voltage. Suppose we connect, what is the output voltage we are getting here? What is the output voltage that we will obtain here? This is the answer on the ammeter. We had to show this answer, and for this we are going to use this formula, Vs over Vp is equals to Ns over Np. Vs divided by 24. Vs means secondary voltage, that is what we need to calculate here, and Vp means that the primary voltage, that is given 24 volts, so we are using 24 volts. Ns, that is the 720 coils, number of the turns of the secondary side, that is given 720, number of turns of the primary, and that is 240. This formula, remember, easy to how I can easily remember this formula, because Vs is directly proportional to Ns, Vp is denominator, Np is also in the denominator. So overall multiplication, this 0 is cancelled out by this 0, 24 goes towards the other side, comes here 24 can be cancelled with the denominator, answer is 72. Therefore the output voltage is 72 voltage AC. This is a step up transformer. So finally this is the end of the episode 20, and coming up next, eddy currents. Hopefully you like our episode, and stay tuned, watch and grow.